So we're going to be looking at deriving the law of sines. And you can see that this is our big picture, which we know we have for each 9 weeks. This is Unit 10. We're doing Lesson 4, which is on Day 6. And you can see that it is a 1-day lesson, and then we have 1 day for law of sines, and then the 3rd day is applying or application problems for law of sines and law of cosines. Then if we look at the scope and sequence, remember it tells us how many days for this lesson. It tells us what course of study objective. This is number 38. And then it gives you a teacher's note with a little bit of information, some prerequisite skills, and then it gives you material needed. Your students will need a scientific or a graphing calculator. And then it gives you some presentation strategies and some technology tips. So let's look at this first part of the lesson. It says find the lengths of D and E. So if I do, using right triangle trig, sine of 60 equals, so here's 60. If I'm doing sine, I'm doing opposite over hypotenuse. And to put that in the calculator, I do 5 divided by sine 60. And that gives me 5.77. Now, so that gives me what E is. Okay, so I know E. So I still need D. So if I use tangent, I can do tangent of 30 equals opposite over adjacent. And to put that in the calculator, all I have to do is multiply both sides by 5. So I do 5 times tangent of 30, and I get D equals 2.88. Well, since it's a special right triangle, 30, 60, 90 right triangle, I know that the long side is equal to x times the square root of 3. I know the short side is equal to x, and I know the hypotenuse is 2x. So if I take this equation right here, then that gives me 5 divided by the square root of 3 equals x. So now I know this side is 5 divided by the square root of 3, and this side is 2 times 5 divided by the square root of 3, which is 10 divided by the square root of 3. And if you want to rationalize those, you can. So either method is fine. Well, that was a right triangle, so we had a couple of options there that we could use to find those 2 missing links. But look at this triangle. We know this angle is 30 degrees. We don't know what angle Z is or angle Y is. So we don't have a method of finding out those missing side links at this point. So we need to figure out a way to do that. So this says write an expression using sine for H in terms of angle A and for H in terms of angle B. So if I do sine of A is equal to, well, here's A, sine would be, and this is a right triangle here, sine would be H, opposite, over hypotenuse. And sine of B would be, here's B, so sine is opposite over hypotenuse, so H over A. So then it says solve for H in each equation. So I'm going to multiply this side by B, both sides by B. So that gives me B sine of A equals H, and A sine of B equals H. Well, now these are both equal to H. So it says equate the answers above and then rewrite as a ratio with A on one side and B on the other. So I can, because this is equal to H and this is equal to H, I can say B sine A equals A sine B. So now I want to get this where I have A on one side and B on the other. And that means the big B and the little b. So let's divide both sides by AB. If I do that, this B over B equals 1, so they divide out. This A over A equals 1, so they divide out. So I'm left with sine of A over A equals sine of B over B. Now I have the A's on one side and the B's on the other. This equation is called the law of sines and can be used when two angles and one side length are known. So we can also from here say that sine of C over C. All of those are going to be equal. So now that we know the law of sines, let's work a problem with it. So we have this problem. A surveyor needs to determine the distance from A to B, and they lie on opposite sides of a river, and they tell us that from point A to point C is 160 meters, and they tell us that angle A is 41 degrees and angle C is 55 degrees. Well, if these two angles are 41 and 55, that equals 96 degrees, so we know angle B is 84 degrees because we know all triangles add up to 180 degrees. We can also label the sides of our triangle. If this is angle A, this is side A. If this is angle C, this is side C. And if this is angle B, this is side B. You always label the opposite side with the lowercase of that letter. So we have a side length and an angle that go together. So we're going to start with that. Sine of 84 over 160 equals sine of 41 over A. And then we can do the same thing again. Sine of 84 over 160 equals sine of 55 over C. And to put these in our calculator, we simply take, cross multiply, and divide. Now, we don't really need to solve for A because it didn't ask us that length. What we really need is this length because the surveyor needs the distance between A and B. So we're going to do, in our calculator, sine of 55 times 160, sine 55 times 160 divided by sine 84 equals. And when you put that in your calculator, you're going to get, and that's going to equal C. So C equals 132 meters. So you need to finish this lesson, and then there will be a Google Sheet, and two of you will be asked to present problems 1 and 2. We will have 3 more lessons, and each of you will get 1 problem to present out of the 4 lessons.